Hello, this is Sabir Malli. The topic of our discussion in this video is the college algebra you need for calculus. First, we will review what is addition, multiplication, and division for a single expression. So I will begin with the operation addition, how to perform the addition if you have two single terms in your expression. For example, if you have to add x square with 3 times of x square, how to perform that operation. So one thing to notice that you can only perform the addition operation between the two terms which has same exponent. As you can see that here I have x square, means basically the exponent of the x square term is 2, and here the second term is x square also, so it have a same exponent, so I'm allowed to perform the addition operation. So the addition operation is essentially is the operation between the coefficient of these two expressions, which is 1 plus 3, and then you have x square outside. So this will gives you 1 plus 3 is 4, give you 4 x square. Let's consider one more example. Let's suppose you have x to the power 1/3 plus 5 times x to the power 1/3. So as you can see that the exponent for the both term is 1/3. So we can add these two expressions and we will perform the addition between the coefficient of 1/3 and also the coefficient of 1/3 for the second term. If there is nothing in front of the term, it means the coefficient of that term is 1. So 1 plus 5, it will give us 6. So 1/3 will stay as it is. So you have a 6x to the power 1/3. Let's add x to the power 3 with 4 times x to the power 3. In the same way, in the same manner, you have x to the power 3 outside, and inside of the parentheses, we will have the coefficient of these two terms. So the coefficient of the first term is -1. As you can see, if there is nothing in front of the x cube, so it is coefficient is negative times 1, and then this one is 4. So this gives you 3x cube. One more term, let's suppose you have 1/3, -1/3, and you have to add in x. How you perform that operation? As you can see, the exponent of both term is x to the power 1. So I put x to the power 1 outside, and inside of the parentheses, I will put the coefficient of these two terms, and then I will perform the addition or subtraction operation, whatever the sign they have. So 1 minus 1/3 is 2/3. So this will be a 2/3 times x. Our next operation is multiplication. How to perform the multiplication between two single expression. So let's, for example, we have to multiply x to the power 2 with the term x to the power 3. So multiplication is performed when you have the same base. So here you have x to the power 2, where base is x, and you have x to the power 3. The base of these two terms is same, which is x. And the multiplication is performed by adding the exponent of these two terms. So in this case, it will be a 2 plus 3. So our final result will be x to the power 5. Let's consider one more example. Suppose I need to multiply 1/3 with x to the power 2/3. In this case, I have same base, so I can add the power. It's gonna be a 1/3 plus 2/3, and this 1/3 plus 2/3 is 3/3, which is a 1. Therefore, it is just x to the power 1, which can also be written as just x. Let's take one more example. Let's suppose you have minus 1/3 multiplying to x to the power 2/3. In this case, same manner, we will add -1/3 in positive 2/3. which will be same as x to the power -1 plus 2 divided by 3. So which will give you x to the power 1/3. One more example, x to the power 5/3 multiply to 2 times x to the power 1/3. So you can see this 2, it will not be multiplied to the power, it will just came outside, and you will perform the operation between the same exponent which these two term has. So therefore this will be a 5/3 plus 1/3. So 2 will stay outside of the multiplication of these two expressions. So in this case, I will get 6 divided by 3, which is a 2. So 2x square. Our next operation is how to perform the division operation between the two single expression. Division operation is essentially a multiplication operation, but we have to do one more step before we perform the multiplication operation. Let's take an example. So let's suppose you have x to the power 2 divided by x to the power 3. The first you have to write this term as x square multiplication x to the power -3. So you can move the single operations in the denominator by changing the sign of the exponent. As you can see here, I changed the sign of the exponent from 3 to -3. And now I can perform the multiplication operation, which I performed in the previous slide. So it will be a -2, 2 minus 3, which gives you x to the power -1. And when you have the negative exponent, you can always move that in the denominator by switching the sign of the exponent. So it will be just x to the power 1. Here there is a one note. You cannot, if you have more than one term in the denominator, you cannot move these denominator term in the denominator by just switching the sign of the exponent. Like by doing this, it will be not a correct math. So avoid this type of situation where you have the exponent, there are more than one exponent, there were more than one term in the denominator. So this is a wrong terminology, so avoid it. Let's take some more examples of the operation. So let's suppose you have x to the power 1/3 and it is divided by x to the power 2/3. So basically this division you can perform between x to the power 1/3 by moving 2/3 by changing the sign of the exponent in the denominator. So you have x to the power 1/3 minus 2 times 2/3. So you have x to the power 1/3 minus 2/3, which if I add them, you will get basically minus 1/3, which can also be simplified to 1 over x to the power 1/3. So you can always move the negative exponent in the denominator by changing the sign of the exponent. Our next topic is how to perform the operation addition, multiplication, division for long expression. That is when in your expression you have two or more terms. But for examples, we have two expression x square plus 3x plus 1, and you want to add this one in another expression, which is a 2x square plus 4x minus 9. So how to perform this addition operation? The first step of this process is we will collect the term which has same exponent. For example, in this term, I have x square and 2x square. They have same exponent, so I will group them together. And then I have a term 3x and then have 4x. I will group these two terms together, and the last I will group the constant term together, which is a 1 and 9. So now I have these two expressions which can I use the previous method to add them. So therefore, these two expressions will be added as 1 plus 2x square. This expression in the similar manner I can add by adding 3 and 4 and multiplying x outside. And this is the simple subtraction between 1 and 9, which is a negative 8. So this will give me 3x square plus 7x minus 8. Let's take one more example. In this case, my second example is if you have to subtract two expression, like let's suppose x square 3x plus 1. If you have a negative sign, 2x square plus 4x minus 9. So before you perform the operation, you have to distribute the negative sign to each term. So this will be x square plus 3x plus 1 minus 2x square plus 4, sorry, minus 4 minus 4x plus 9. And next we will group these terms together. So this will be x square minus 2x square. This will be in one group, addition sign. This the second group will be 3x and negative 4x. And the last group will include the constant term, which is 1 and 9. And now I can perform the addition and subtraction operations between two terms. So this will gives me minus 1x square. This gives me minus 1x, and that is 10. So which also can be written as minus x square minus x plus 10. Our next operation is multiplication operation between long expression. We will take this example 2x plus 1 and let's suppose x minus 3. So to perform the multiplication operation, we will use the method which is called FOIL. So FOIL, and I will basically add them. In the FOIL word, F represent first, O represent outer, and I represent inner, and L represent the last terms. So first we will take the first terms of these two expressions, which is a 2x, and the second expression, first term is x. So we will multiply the first term, then we put the addition sign, and then we multiply the outer term, which is, you can see 2x, and it is a negative 3, and we plus add the addition sign, and then we multiply the inner term, which is a 1 and x, and we add the addition sign, and then we basically take the last term, which is a 1 and negative 3. So this is the meaning of FOIL: first, outer, inner, and then last. Now we will perform these multiplication and addition operations as we did in the previous slides. So the first is a multiplication operation is going to be 2x square. The exponent of x and x will add, which is 1 plus 1, 2. This will be just simply 3 multiplying to 2x give us 6x, and this is just 1x, and this is a constant term, which is a negative 3. So as you can see that this term can be grouped together because they have same exponent. So I can add or subtract these two terms. There is no x square, so this is the only x square I have is a 2x square term, and therefore I will add minus 6, the coefficient of x, and then the second term coefficient is 1. I will put x outside, and negative 3, which is a constant term, will stay as it is. So this will give me 2x square minus 5x minus 3. Let's take one more example. Here we will also use the FOIL method to simplify this expression. So our first term is a 5x to the power 2 third in the first expression, and the first term in the second expression is x to the power 1 half. Then we will add a plus sign, and then we will look for the outer term. In the first expression, our outer term is 5x to the power 2 third. In the second expression, our outer term is just 1. Then we will look for the inner term. In the first expression, our inner term is 1, and in the second expression, our inner term is x to the power 1 half. And the last term in both expression, they are 1. So now we will perform the multiplication and addition operations. So multiplication only happens when you have the same base on their exponent. So this will be 2 third plus 1 half. So this is simply 1 multiplied to anything is just same term, and x to the power 1 half here, and then just 1 here. Sorry, x to the power 1 half. Now let's simplify this a bit more. So this is a x to the power 2 third plus 1 half. So in order to add these two exponent, I need to multiply this exponent to 3 and this to 2. So I will multiply on the top also. So I will get 2 plus 3, and the common denominator is 6. And then I have 5x to the power 2 third, and then you have x to the power 1 half plus 1. So this become x to the power 5 6. So 5x to the power 5 6 plus 5x to the power 2 third, and x to the power 1 half plus 1. Since no exponent are same, so this will be where we can end our simplification, because no further simplification can be done. Our next topic is how to perform the division operation between the long operations. So division operation is a very interesting and a bit more challenging operations to perform. So let's for example, I have to add 2x square plus 3. This is x plus 1, and then I have to add x plus 1 divided by x plus 2. How to add these two rational expression? To add and subtract two rational expression, first we will need to make the same denominator. So here we will need to find a term which we will multiply to the denominator, the first denominator. So I can say this is x plus 2, and I need to find a term which I multiply to the second denominator. In this case, my term is x plus 1. So when I will multiply these two terms, the denominator of my both the expression becomes same. So as you can see, in this case, my denominator is x plus 1 times x plus 2. So if you multiply some things in the denominator, you have to multiply the same expression also in the denominator, because this is the rule of balance. So you have to balance it out, because you multiply something in the denominator, and you have to multiply the same expressions also in the denominator. So I will multiply x plus 1 both in the top and in the bottom. Now all I need to do is basically I have a common denominator, so I will draw a common line, and I will place the common denominator in the denominator term, and the denominator term will be this time x plus 2, which is a multiply to 2x cube plus 3. Here the operation will be whatever the operations we have here. So since we have addition operation, so we will keep that operation here. And then you have x plus 1, and this is a multiplying to x plus 1. Now we will basically perform the multiplication and addition operations in the denominator. So as you can see, if I use the FOIL method, I will get 2x to the power 4 plus 3x plus 4x cube plus 6. Similarly, I will FOIL the second term. I will going to get x square plus x plus 1, and whole entire thing is divided by x plus 1, x plus 2. Now I will perform the addition operation, and addition operation will be performed between the same term which they have same exponent. As you can see that x to the power 4 is only a one single term, so it will be stay as it is. How many term we have with the exponent 2 is only a one term, so it's gonna be stay as it is. Similarly, 4x cube, this term has only one exponent expressions in the whole denominator, but we have 3x, then x and x, so it's going to be a 3 plus 1 plus 1. So these three expression will add together, and then we have the constant term which is a 6 and 1. So this whole entire thing is divided by x plus 1 and x plus 2. So after the simplification, we will get 2x to the power 4 plus x square plus 4x cube plus 5x plus 7, and it is divided by x plus 1 and x plus 2. So this is our simplified expression. Let's take one more example. Here I have an example which we have 1x plus 1 is subtracted to 1 over x. And again, I will begin by multiplying something in the denominator, the first denominator, and something in the second denominator, so that both the denominator will become same. So here I will multiply by x, and if I multiply this by x plus 1, so as you can see, my same denominator in this case is x and x plus 1. So if I multiply something in the denominator, I also have to multiply that in the denominator. So I will multiply this term, which is x in the denominator here, and also have to multiply x plus 1 in the denominator as well. So you have x here. So here sign will be whatever the sign is here. This sign is negative, and then you have x plus 1. So do not forget the parentheses, because it's very important when you have a negative signs in between the two expression. So now I simplify. This is x, negative sign will be distributed, so it's going to be a minus x, and it's going to be negative 1. So it's going to have x plus 1, and this, you see that if I add 1 and negative 1, it will be 0. So 0 times x is 0. So I will just x divided by x times x plus 1. Let's take one more example. In this case, let's take this example, x square plus 1 minus x square, 2x square times x square plus 1 to the power negative 1 half. So here, if I have to subtract these two expressions, we will see that how we will use the division operation to perform, to simplify this expression. So I will begin first by taking this symbol as 1 half, right? I will first begin by writing the radical as 1 half. Then you have, this is a 2x. So as you know that if the exponent is same, I can move that exponent in the base. So I have x square plus 1 to the power 1 half. So here, once you don't have any denominator, you always have 1 as a denominator term. So in order to add these two expressions, I need to make the same denominator. As you can see that if I multiply 1 by x square plus 1 to the power 1 half, and I just multiply this to 1. I don't need to multiply any term to basically the second denominator. And this is a x square plus 1. I have to also multiply in the denominator. So now I have the expression which the same denominator x plus 1 to the power 1 half is my common denominator. So here I have the expression x square plus 1 to the power 1 half and x square plus 1 to the power 1 half and negative sign because the negative sign is between these two expression, and we have a 2x square. Now we know that when you have the two same radicals, they multiply to each other and they cancel. So this is the radical and this radical, they will cancel to x square plus 1, and then you have 2x square and divide by x square plus 1 to the power 1 half. And x square and minus 2x square, they will add to minus x square, and you can write the radical as x square plus 1. So this is your simplified expression. Our next topic is how to solve some polynomial equations for x. So let me start with this example. Suppose you have 4x plus 3 is equal to negative 2, and you would need to find the values of x, how to solve this equation and find this value x. So the solution is goes step by step. In first step, what we do it, we move all the term which do not contain x on the right hand side by performing the additions and multiplication operations. So if I add negative 3 on both sides, I would be able to remove the constant term 3. So I will get 4 is equal to negative 5. Now I would like to get rid of 4. So if the expression is in the multiplication, the division operations will remove this 4. So I will divide 4 on both sides. So I will have x now, which will be 5 divided by 4. You can also verify your answer that whether you get the correct answer or not. So if I place negative 5, 4 into my original equation, I should get the left hand side is equal to right hand side. So let's suppose if I plug uh, minus 5 divided by 4 in this expression and add 3, I should get this is equal to negative 2. So as you can see that this negative 4, this 4 and that 4 will cancel out. I will have negative 5 plus 3, and negative 5 3 is in fact 2, which is equal to the right hand side. So my expression or the value of my x which I calculated, it is correct. Let's take few more examples. Let's solve these expressions. As you can see that I can first begin by adding negative 3 on both sides. So I will get pi. Pi is a constant which is value is 3.14, and if you do pi times x, it will use 6. Now in order to get rid of pi, I will divide the pi on both sides. So my value of my x is 6 divided by pi. Let's suppose take example 2x square negative 1 is equal to 0. Now I have a polynomial of degree 2, and again I will begin by adding 1 on both sides. So if I add 1 on both sides, I will get 2x square is equal to 1, and then I will divide by 2 on both sides. So that give me my x square. First I was able to separate my variable x. Now if I move that 2 on the other side, I need to take the 1 half on both sides in order to get rid of this 2. So this will be 1 half raised to power 1 half. So when you take the power 1 half, it always comes with the plus and minus sign. So therefore, in this case, our expression will be x raised to power 1 over square root of 2, because 1 half can also be written in terms of the radical expression 1 half, 1 over square root of 2. So this is our two solution in this case when you have quadratic expression. Let's suppose if you have x to the power 3 minus 1 is equal to 0. So you will begin in the same manner by adding first 1 on both sides, will give you x 2x cube is equal to 1. This time x cube give you 1 over 2. And if you take the 1/3 on both sides, you will get x is equal to 1 over 2 to the power 1/3. So basically that moving the power on the other side is just reciprocating the power. So there is a one thing to be noticed, that when you have the odd term, so if you are taking x to the power n, for example, is equal to a, when you are moving that power on the other side, if n is a odd, then you have only positive sign. But if n is odd, but if n is, or the power is even, then you have a plus minus sign. So for even power, plus minus, but for odd power you only use the plus sign. So this is important observations, that when you have the power positive and you want to move that power on the other side, you have to look for whether your power is even or odd. So even power give you the two values of x, however the odd power will give you only one value for that expression. Let's take one more expression. This time this is a 4x to the power 1/3 is equal to 14x to the power 1/3 plus 1. Let's take now this expressions and let's now take this expression and solve this expression for x. So first we will try to move every term which do not have x on one side and which have x in one side. So I will begin by multiplying or adding -4 on both sides. So if I do that, I'm gonna have 4x to the power 1/3 is equal to 14x to the power 1/3, and I'm gonna have -3 here. Now I would like to move that term also on the left hand side. So I will add 14x to the power 1/3 on both sides. So as you can see that when you have the same exponent, you can add the coefficient. So 14, 4 minus 14x to the power 1/3 will be is equal to -3. So this gives you basically -11 x to the power 1/3, and this gives you -3. So negative sign can cancel out from both sides, or therefore x to the power 1/3 will be 3 divided by 11. Now you want to move this power on the other side. So therefore x will be, when you move that power on the other side, it reciprocates. So 1/3, the reciprocal of 1/3 is just 3. So this will be the value of your expression x in this situation. Next, we will learn how to solve the expression which involve the exponential function e to the power x and also natural log of x. So let's take this example. So when you have an expression which involve e to the power s, to solve that expression, the first we have to separate the exponential function. We will take the exponential function on one side and move all the term on the other side. So I will start by moving first the constant term 3 by adding -3 on both sides. So this gives me e to the power 2x is equal to 2. Next is I will get rid of 2 by dividing 2 on both sides. So this gives me e to the power x is equal to 1. So when you have the expression exponential fraction on one side and some constant on the other side, you will take the natural log on both sides, and we will use this property since the natural log of e to the power x is always equal to x. And we will use this important property of the natural log. So natural log of e to the power x is equal to x. So this expression will become x is equal to natural log of 1. And we also know the natural log of 1 is 0. So this implies x is equal to 0. You can also verify these expression by plugging back into the equation. So you can see that 2 times e to the power 0 plus 3 is equal to 5. Yes, because e to the power 0 is 1, 2 plus 3 is equal to 5, and 5 is equal to 5, which is a true expression. Our next example is when you have to solve the equation which involve the logarithm function. So again, the procedure is same. We will move all the term which do not involve natural log of x by additions or by adding or subtracting or multiplying or dividing some expression. So this time I will basically add a -3 on both sides. So I go to natural log of x -2. Then I will divide by 2 on both sides, and I will make the natural log expression on one side and some constant on the other side. Then in this step, then in the next step, we will take the exponential function on both sides. So if I take e to the power natural log of x, and I will take the constant on the power on the exponent of e. Here I will use this important property e to the power natural log of fx is simply x. They both cancel to each other because they are inverse to each other. So therefore this expression just gives you x, and here you have e to the power -1, which also can be written as 1 over e, because if you have negative exponent you can move in the denominator. So the solution to this problem is x is equal to 1 over e. Our next topic is solving the quadratic equation by using the factoring method or the quadratic formula. So let's take an example. X square plus 2x plus 1 is equal to 0. This is a quadratic equation. First, I will use the method which is a factoring this polynomial, and using that method, I will find the value of x. So when the coefficient of the highest degree, in this case, which is a x square, is 1, so which you can just basically factor it simply taking x minus some number and the x minus the second number is equal to 0. How to find these two numbers? So in order to find these two numbers, you will take the middle term of this polynomial, which is a 2, and then you take also the last term, the constant term, which is 1. So you will find the two number which will add to the middle term, in this case 2, and they also should multiply to 1, which is the constant term of the polynomial. So as you can see, if I take 1 and 1, they will both add to 2, and 1 multiplied by 1 is 1. So these two numbers are satisfy these conditions. So I will just simply place these two numbers here, and these will be my factor. So once I have the factor, because since this is the product of two factor and they are set then is equal to 0, I can set each factor is equal to 0 to solve them. In this case, I will get x is equal to 0, x is equal to 1, and x is equal to 1. This will be my factor. This will be my, in this case, I will get x is equal to 1 and also x is equal to 1. So I have one root, which is x is equal to 1. It is in fact is a repeated root because it will repeat twice. Let me take one more example. So here is another example of a polynomial x square plus 5x plus 6 is equal to 0. So again, since the coefficient of x square is 1, so I can just simply factor this polynomial in one step. All I need to do is I need to find two number whose additions is 5 and multiplication is 6. So I can see that the number 3 and 2, they will add to 5, and they also multiply. The multiplication is 6. So 3 and 2, they will be my these two number, and I will place these number in these factor. So the next step is I will set each factor is equal to 0 and solve them. So in this case, I will get x is equal to 3, and from this factor, I will get x is equal to 2. So I have two root of this polynomial, which is a 3 and 2. Let's take one more example. So this time our example is x square minus 3x minus 10 is equal to 0. So since the coefficient of x square is 1, so I can just factor this one in one step. So all I have to do is I have to find the two numbers, they add to -3, and the multiplication of these two numbers must be -10. So as I can see, -5, +2, then these two numbers will add to -3, and -5 and 2, if I multiply these two numbers, their multiplication will be -10. So I simply place -5, so negative will +5 here now, and here it will be 2. So next step of the simplification will be, I will basically set x plus 5 is equal to 0, and then I will set x minus 2 is equal to 0. So in this case, I will get the root x is equal to -5, and from this polynomial, I will get the root x is equal to 2. So these are my two root of the given polynomial. Here I have one more example, and in this example you can see that the coefficient of x square is not 1, in fact it is 2. So we will not be able to factor this polynomial in one step. So in this case we will use the AC method. So let me show you what is AC method. So to use the AC method, first is you have to locate the coefficient of the middle term, which is a -1 in this case. And then you will compute the AC term, which will be the coefficient of the first term. So this is a A, this is a B, and this is a C. The coefficient of x square will be A, and the constant term will be C. So if you multiply A to C, you will get -2 here. So the method will be same from here on. So you need to find two numbers, they will add to -1, and this time they will multiply to -2, which is a AC. They will not multiply to just C. In the last example, it was only C, which was -1. So as you can see, if I take the number 2 and number 1, they will, as you can see, if I take the number -2 and 1, they will add to -1, and also these two number will multiply to -2. So these are my two number which I will use. So next step of the calculation will be x square. We will break the middle term into these two pieces which I just found. So it will be -2x plus 1x. So because this is -1 can be written as a -2 plus 1. So I break the -1 into two pieces, and then that C will be as it is. In the next step, we will group these first two term and then last two term. And as you can see, I can pull out the common factor. which is a 2x. So then I have left with x minus 1. And if I pull out neg 1, then I will get x minus 1 is equal to 0. Now x minus 1 is a common factor between these two terms. So I can pull that factor. So I will get 2x plus 1 is equal to 0. And now I have the product of two polynomial or two linear polynomial is equal to 0. I will set the each polynomial is equal to 0 to find the root. So when I solve this linear polynomial, I get x is equal to 1. When I solve this one, I will get x is equal to 1 half, negative 1 half. So these are my two root in this case. And this is a different method which is called AC method. This is a bit more challenging than the math than factoring when you have the coefficient of x square is just 1. So we will use the quadratic formula to find the root of any quadratic polynomial. My first example is 2x square minus x plus negative 1 is equal to 0. So what is a quadratic formula? If you have a quadratic polynomial ax square plus bx plus c is equal to 0, then you can find the root by using this formula, which says minus b plus minus radical of b square minus 4ac, and whole thing is divided by 2a. So this is our quadratic formula. So if I compare my example with this general form of the quadratic equation, I first need to locate what is my a. A is in this case 2, which is the coefficient of x square. B is the coefficient of the term x. In this case, this is a negative 1. And C is the constant term. And in this case, it is also negative 1. So when I plug these values A, B, and C in the quadratic formula here, I will get the root of my quadratic polynomial. So here you can see there is a negative sign. So, and then is a negative 1. So minus 1 plus minus radical of b square, which is negative 1, the square of this, minus 4 times a is our 2, and b is our negative 1, and this is a divide by 2a, and in this case our a is 2. So this is our quadratic formula when I fill the values of a, b, and c in it. So next is we will simplify this formula. So negative, negative, positive. So I will get positive 1 here, plus minus radicals. Here 1 square. So if you have a negative and the square of 1, it means negative 1 times negative 1, which will become a positive 1. And here is a negative 4 times 2 times negative 1. It will be positive 8. And this is the whole thing is divided by 4. And then we will simplify 1 plus minus radical of 9 divided by 4. The radical 9 is 3, so it's a plus minus 3 divided by 4. So now in order to find the two root, first I will use the plus sign. So I will write 1 plus 3 divided by 4. And in order to find the second root, I will use the negative sign, 1 minus 3 divided by 4. So this gives me my first root is a 4 divided by 4, which is a 1. And I have another root, which is 1 minus 2, which is a negative 2 divided by 4. Or in other words, this is a negative 1 half. So these are my two root of this quadratic polynomial. I have one more example here, which is x square plus 5x plus 3 is equal to 0. So as you can see that you will not be able to find the root of this polynomial using the method factoring, because you will not be able to find the two number which will add to 5 and they multiply to 3. So in this polynomial, we must have to use the quadratic formula in order to find the root of this quadratic polynomial. So here, if I compare this quadratic polynomial with my journal form, so I will get a is equal to 1, b is equal to 5, and my constant term c is equal to 3. Then I will use my quadratic formula, which is a minus b plus minus radical b square minus 4ac divided by 2a. So if I plug the values of a, b, and c into this quadratic formula, I will get minus 5 plus minus b square, which is 25, because 5 square is 25, minus 4a is a 1 and c is 3. And it is divided by 2a, or another word 2 times. So this will be minus 5 plus minus radical of 25 minus 12 and divide by 2. So therefore this is equal to x is equal to minus 5 plus minus, this is a radical of 13 divided by 2. So you will get the two irrational root. Our first root will be minus 5 plus radical of 13 divided by 2. And then you have another irrational root, which is in term of radical also, by using the negative sign. So when the polynomial have irrational root, they cannot be factored easily. Our next topic is how to evaluate a function at some specific value of x. For example, the function in the calculus is mostly written as f of x is equal to, let's suppose 2x square plus 3x plus 1. And you would ask to calculate this function at some value. Let's suppose our first example is, if we calculate at when x is negative 2. So what that means is basically you're going to take x as a placeholder in the function. So our function is a 2x square. So I will take the x as a placeholder. And then x is my 3 times x. So again, I took the x as my placeholder. And I will place this value, which is inside the parentheses of the function. So which will be here negative 2, negative 2, and there is no more parentheses. So this will be all I have to do. So now I will simplify. So as you can see that when you have the even exponent of any number or any negative number, it will make that number positive. So you will get negative 2, the square of that, positive 4. This will be negative 6, and that will be plus 1. So this is 8 minus 6 plus 1, which is same as, let's evaluate in some different values. Suppose evaluate at 1/3. Then I will take this placeholder again the same way, the square of that, 3 times this and plus 1. So wherever I see the placeholder, I place 1/3 in there. And then I will simplify. This will be 2, and the square of 1/3 is 1/9. And 1/3 times 3 is 1 plus 1. So this will be 2/9 plus 2. And you can simplify further. That will be 9, 2 plus 18, or another word, 20/9. Let's look at another problem. In this examples, we will not place a number. Instead, we will place some constant, which is a plus x. So if you plug a plus x, it will be the same procedure. You will take x as a placeholder first. And similarly, you place a plus 1 in the placeholder. And then you have to simplify this one. So this can be written a plus 1 square as a plus 1 times a plus 1. And this can be FOIL to 3a plus 3 plus 1. And I can use the FOIL method on these two factor, which is a plus 1 to FOIL them out. It's going to be a times a square, then a plus 1 times 1, parenthesis close. This will be a 3, and 3 plus 1 is 4. So this is a 2 outside, and inside the parenthesis a square plus 2a plus 1, and this is a 3a plus 4. Now I will FOIL the parenthesis. It gives me a square. I'm distributing 2 inside the parentheses. And now we will perform the last operation, which is the addition operation. This is a square. This a, 4a, and this is a 3a. They will combine to 7a. And this 2 and that 4, they will combine to 6. So this is our expression, which is a simplified version of the value of the function is a value. Let's take one more examples. In this examples, we will evaluate the function at some function value x plus h. The procedure is going to be almost similar. We will first step is we take the x as a placeholder, and we will place the same whatever is here in the parentheses of the function, which is x plus h, and this is x plus h. We will place it there, and then the very first term of the expression, we will FOIL it out and simplify. So this will be a 2x squared plus 2xh plus h square, and I FOIL this out, and this will be x plus h plus 1, and I will distribute the 2. It's going to be a 2x squared plus 4xh plus h square plus x plus h plus 1, and I think this is all the simplification we can do. So this is a 2x square plus 4xh plus x plus h square plus h plus 1. So I basically separate the h term, and then I move the x term different, but you can also stop it here. Next topic is slope and equation of line. In order to find the equation of the line, you need the 2 points to calculate the slope of the line, and then to find the equation of the line, you need the slope and 1 point. So let me first give you the formula of the slope and the equation of the line, and then I will show you some examples. So if you have given the 2 points, let's suppose x0 and y0 and x1 and y1. To calculate the slope of a line which passes through these 2 points, the formula is y minus y value, see difference of y value, which will be your rise, and x minus x value, or the difference of your x value. So this is a rise, and that is a run. So that's why it's called rise over run is the slope of the straight line. So the one formula is y minus y value. So you can choose any point. I will choose the first point. Slope time x minus x value. So you pick one point and you pick the slope, and you write that formula y minus y value is equal to slope time x minus x value. And you can also use this formula which say y is equal to mx plus b, and where you have to calculate the b by using one of these point. So these formula are essentially same. One is written in a bit more simplified form, and one is basically not in a simplified form. So, but sometimes the formula 1 is easier to use and sometimes the formula 2 is easier to use. It's depend on the situations or on the problem. So let me give you an example. Suppose you have a point 1 comma 2 and negative 2 comma 3, and we would like to find the equation of the line which passes through these 2 points. The first we will calculate the slope. Slope will be y minus y value, which will be 3 minus 2 divided by x minus x value. So corresponding x value of this point is negative 2 minus 1. So top will be 1 and bottom will be negative 3. So you will get the slope of the line is minus 1 divided by 3. I will use the first formula to calculate the equation of the line. So if I want to calculate the equation of the line, I will use this point. I can use also negative 2 and 3, but this time I will choose this. So y minus y value, which is a 2. The slope is a 1/3 and x minus x value, which is 1. So if I simplify this equation, y minus 2 is equal to minus 1/3 x plus 1/3, and then I will add 2 on both sides. I will get y is equal to minus 1/3 x plus 1/3 plus 2. So this is simply y is equal to minus 1/3 x plus 7/3. So this is the equation of the line. This is also the end of our video. Thank you very much for watching. I will see you in the next video. Bye for now.